Yeah, thank you so much. Welcome to Mathematics Solutions. Suppose you've been given a question to expand a cos 3 theta and sin 3 theta using the Moivre'S theorem, and hence you write an expression for tan 3 theta. Now, the first thing you have to is to state the Moivre'S theorem. So the Moivre'S theorem states that z raised power n is equals to r raised power n into cos n theta plus j sin n theta. And this we call it equation number 1. So it being equation number 1, where this n is equals to 1, 2, 3, we remember that the polar form of a complex number is given by z is equals to r into bracket cos theta plus j sin theta. Now, if you can raise to power n, if you can raise power n there, and also again can raise power n on the other side, both sides, then you're going to get z raised power n is equals to r raised power n cos theta plus j sin theta raised power n. We call this equation number 2. If you can check equation number 2 and equation number 1, the left hand side are both z raised power n. And this implies that the right hand side of these two equations are equal. The right hand side of this one is equal to the right hand side of this one. Now, so equating on that, we'll get that cos n theta plus j sin n theta is equals to cos theta plus j sin theta, and then let's power this n. Now, from our question, if we want cos 3 theta, then it means that our n is 3. So if you can come down here, we substitute our n by 3, we are going to have cos 3 theta. This one will be 3, and this one will be 3. And also the power here will be equal to 3. So we're going to have cos 3 theta plus j sin 3 theta is equals to cos theta plus j sin theta raised power 3. Now, expanding this expression using Moivre'S theorem, it is kind of tedious when you use cos theta and sin theta. So let us choose this one, cos theta being equal to a, and j sin theta being equal to b. So that is, we have a is equals to cos theta and b is equals to sin theta. So this implies that a plus b cubic will be equal to a cubic plus 3a squared b plus 3b squared plus b cubic. And this is from Moivre'S theorem. Now, going by that, we substitute back our a and b. We have cos theta plus j sin theta, all of it cubic, being equal to cos cube theta plus 3 cos squared theta j sin theta, which is our b, plus 3 cos theta into j sin theta squared, then plus j sin theta, all of it being cubic. So the whole of this thing is cubic. From there, we can open up the brackets. We have cos cubic theta plus 3j cos squared theta sin theta plus 3j squared cos theta sin squared theta plus j cubic sin cubic theta. Expanding the powers of j, j squared is equals to -1. And so therefore it means j cubic, which is equals to j squared times j, will be equal to, -j. So from this equation, star, we have cos 3 theta plus j sin 3 theta being equal to cos theta plus j sin theta cubic. So it implies that I can now equate the expansion of the right-hand side to cos 3 theta plus j sin 3 theta. And that is what we have here. We have cos 3 theta plus j sin 3 theta being equal to cos cube theta plus 3j cos squared theta sine theta minus, this minus comes as a result of j squared. This j squared is equals to -1, so it's going to make this one here be negative. Then minus j sine cubic theta. So this implies that the real part, this one being the real part, this one, the cos is on the real part, and then this one, j sine theta, is on the imaginary part. So if you can equate the real part of the left-hand side to the real part of the right-hand side, you're going to get the expression for cos as this. And if you equate now the imaginary part of the left-hand side to the imaginary part of the right-hand side, you'll get the expression for sine 3 theta as this. And so if you want to simplify, maybe for this, for cos 3 theta to be in terms of cos, you can simplify using the identity. Using the identity, cos squared theta plus sine squared theta is equals to 1. So with that, you can substitute the sine squared with 1 minus cos squared theta, or else you can also substitute the cos squared with 1 minus sine squared theta. So that's the expression for cos. Now, if suppose already we have obtained the expression for cos and for the sine, and now we want to prove the second part of the equation, the expression for tan 3 theta, you're going to say, we should remember the relationship between sine, cos, and tan theta, and that is that tan theta is equals to sine theta over cos theta. That expression. Then after that, this means now tan 3 theta will be equal to sine 3 theta over cos 3 theta. We already have an expression for sine 3 theta, and we also have an expression for cos 3 theta. So of which they are sine 3 theta is equals to 3 cos squared theta sine theta minus sine cube theta. And for cos 3 theta, we have cos cube theta minus 3 cos theta sine squared theta. Substituting the expression on the formula, we have this being the expression for sine 3 theta, and this one is the expression for cos 3 theta. So we want to factorize cos cube theta from both of them. Now, we are using the principle that you can factorize anything from any expression. Like in this case here, you might have been given A plus B is equals to, you want to factorize C, you can bring C outside, but then inside the brackets, you can divide the individual part of the number by C, so that when I open up this bracket with C, I'll get what? I'll get A plus B. So doing that, you're going to have cos theta outside, you're going to have this, then you can simplify, you'll get cos theta, and then the cos theta is also going to be divided by sine, to divide sine cubic theta. On the denominator, when you factorize cos cubic, you're going to remain with 1 here, and then minus 3 sine squared theta over cos squared theta. We remember that tan theta is equals to cos sine squared theta over cos squared theta. So it means this expression here is equals to a tan theta. This one to become equal to a tan cubic theta, and this one here to become a tan squared theta. And so therefore, it means the final expression for tan 3 theta will be given by tan 3 theta is equals to 3 tan theta minus tan cubic theta, or over 1 minus 3 tan theta. So that is the end of our presentation. Thank you so much for watching Math Mike.